we're looking. And what you should definitely have is you should now have your rules. Oh, I can give you all a sticky note if you want to, and you can write your rules and stick it there so you can move it from page to page. But anyway, we've got our 3 rules. What are our 3 rules? What are our 3 rules? Distance, midpoint, and slope. Okay, so we've got them. Now, let's be honest, I'm just recording this, so, are we all the same colour change? Oh, yeah, they're changing, that's good. We did the distance, messing around. Right, here's our 3 formulas, and we should know them, love them, be able to recite them with ease. Ooh, colour change. Waiting for Promethean Man to come. I don't think he's coming to see you today. All right, so we read this question. We look. PQ is diameter of a circle. It's got a centre of 3 minus a half, given that Q is that. Find the coordinates of P. What would be the first thing that you should do? Excellent. Good mathematician would draw a diagram. Okay, ready to be impressed? Oh, a little bit eggy out there, never mind. Okay, we've got the centre, 3 minus a half. It doesn't have to be to scale or anything, but I am going to make sure, where would Q go? Left or right of this point? It doesn't really, but you know, why don't we do it semi-decently? You know, it has to go left because it's minus and that's 3, so minus 1 would go this way, and am I going to go up or down? Up, because it's positive 2 compared to half. So let's just imagine it could be here. Here's Q, which is minus 1, 2. And what we're trying to do is find P over here. And we don't know what it is. Let's call it XY. So you've got a massive decision to make. Distance, midpoint, or slope. It is, absolutely, midpoint. So we whack our midpoint formula. Okay, good mathematics. So that is, I would say, one of the first challenging bits of the question, and I like to think you don't find it challenging at all. Got the formula? What does a good mathematician do now? Sub. And we look at the formula, we understand. MP is the midpoint. So what's our midpoint? Oh, look at them. They called it centre instead of midpoint. Oh, scary hard, I know. So underneath, we will put 3 minus a half. And I can see people's heads down madly copying, so just stop a little bit. We continue on our merry way, and we say, okay, we're going to add the 2 x coordinates. So add the 2 x coordinates. You could say minus 1 plus x. I'm just going to go x plus minus 1. I like to have my unknown first. So x plus minus 1, so that becomes x take 1, divide by 2. So I divide by 2. What's going to be my y thing there? Yep, thank you. Y plus 2 over 2. Well done. And because this is a coordinate, right? It has to be that this point has to equal this point. So this whole x value here must equal this whole x coordinate here. Would you agree? And similarly, I mean, you can predict what I'm going to say. Similarly, that one, correct. Okay? So we can now solve this. We're writing 3 has to equal x minus 1 over 2. And can we solve for x in this case? Absolutely. You read it, x take 1 divided by 2. So to get rid of that divide by 2, we're going to times by 2. So that's 6 equals x take 1. And absolutely, Aidan can see what it is at this point in time. 7 take 1 is 6. So therefore, x is 7. And you guys remember you actually did this last year. He had a question in the test, had a storm. Centre of the circle was the storm. The eye of the storm. The eye of the beholder. Come in, let me just finish this bit. So minus a half has to equal y plus 2. And now we're going to solve that. Now you could cross multiply or times, but same denominators, so wouldn't it have to be the case that minus 1 has to equal? And therefore, y must be -3. So finish off and say that therefore p is 7 minus 3. Again, some of you could probably just suss it from looking at your diagram. So what was the distance from -1 to 3? 4? That means you had to go 4 over that way. What's 3 plus 4? Bang, 7. Right. It's common sense. The reason that we want to use the formulas, Dave, is that sometimes, especially if we have fractions, if it was a mixed fraction, even if it was a decimal, you might make an error. And if you're just going, I'm doing it in my head, I'll say again, David, if you're doing it in your head and you accidentally just get the wrong number because you're talking to someone else, you're thinking, you did a slight mistake in your head, you write down the wrong number, you've got nowhere to go. I can't give you any marks whatsoever, okay? And a question like that might be worth 2 or 3 marks, and you've just gone, oh yeah, no, I don't want those. I don't want those marks. I'd like to tell the teacher that I don't know what I'm doing. Hello?
So would you score less marks if you just worked out the answer without?
So the question is, would you score less marks if you just worked out the question? For these, yes, I want to see some sort of steps and some sort of process. I did say that if you guessed, and not guessed, but if you did it all in your head, what invariably happens is you might accidentally put the wrong answer down. So little things like you might put 3 instead of -3. If you showed all of this working and you accidentally put 3 instead of -3, you're not going to lose as many marks because it might just be, oh, I've seen everything. Oh, you've just done a whoopsie here. Does that make sense? So when I'm trying to mark your work, and also, how do I know you haven't just looked at the person next to you and gone, oh yeah, they said 7 minus 3, I'll just put that down as well. I've got to see your thought process. Yes, you're next, Susan.
The working out in yellow.
The working out in yellow?
You can already see.
Yeah, at this point here, you can skip. No, you could skip again. If you are skipping and you accidentally get the wrong answer because you've made a mistake, that's a risk you're taking and you could lose more marks. But obviously, yeah, there are times when you don't have to put every single process in. Yes?
Can you write the formula at the beginning of the test and then just fill it in?
Can you write the formula at the beginning of the test and then write stuff in? Yes, you can. Again, when you have it right underneath each other, you are minimizing the chance of making an error. If I had $1 for every time I've seen somebody accidentally write, instead of x1 plus x2, they've just done a slope question or a distance question. So guess what they write here? Instead of plus, they put minus. So up to you. No prizes for guessing what formula we're using. Slope. And we will write that one down. So we'll go m equals your choice. You want 1 take 2 or 2 take 1? As in y1 take y2 or y2 take? You like the 2 take 1, okay. Anyway, you write down what you want. Yes, dear.
Would you score less marks here if you put change in this mark?
No. So the question was, would you put less marks if you wrote change in y over change in x? No, I have to really concentrate not to write that for myself because I just want to do it. And you'll find that I'm going to give up soon, writing y2 take y1, and I'm just going to do exactly what you've just said, write change in y but change in x. It is a t. This is a t. Why do you think I do my t's like that? Doesn't look like a plus, that's right. Okay, here we go. Got formula, got information. We're going to sub. So underneath the slope, again, keep everything underneath. So -1 over 3. It says equals, I put equals. Okay, we're going to go y2 take y1. In this case, again, I don't care which is 2 or 1, but I want to start with my unknown. So it's going to be t. Take what? Good. all over. What? 10, take 3, right? So we've gone t, take 5, and then 10, take 3. So this is where, you know, I'm not going to write 10 plus 3. I'm actually going to be bold and say 7. You can mix it up. If you want to write 10 plus 3, you can. How would it be 7? And there's an example of why I did it deliberately. She so did not. Why you should probably write your steps. Oh. And as I'm writing that, I'm going, why are you looking at me? Why is Jordan frowning at me? And that would be why. I feel like it's Friday, but it's only Wednesday. We're now just rocking the alge. So it's minus 1 over 3. T take 5 over 13. Who would like to tell me how I'm going to solve this, please? Excellent. Get rid of the divide by 13. We're going to time, so that becomes minus 13 over 3 equals T take 5. And to get rid of our take 5, we will add 5. So therefore, T will be minus 13 over 3 plus 5. And what's that? 2 over 3? So basically, what we're doing with all the others, we had the distance, we could just sub it into the formula. We had the slope, we had the midpoint, we could just sub. Now, we're doing these questions where we can go around. Now, people are looking at me funny again. Why? Is it 4 over 3? Sorry, I jumped the gun and people were going. So, to get t by, hello, can I say, to get t by itself, I have to get rid of the take 5. Do we agree? So how do I get rid of a take 5? Add 5. So this would actually be minus 13 over 3 plus 5 equals t. Agreed? Isn't that the same as t equals minus 13 plus 5? Like minus 13 plus 5 equals t is the same as t equals minus 13 plus 5. Right, so obviously the question is, and how do we add these together, just in case someone else was asking? That's right. Yeah, so obviously you have a calculator, so feel free to use it, but I would like to think you don't need it. So I just change this into 3s. So minus 3 over 13, I go, well, 5 times 3 is? So wouldn't that be the same? 15 over 3, isn't that the same as 5? Now they're the same denominator, so minus 13 plus 15 is 2/3. But don't hurt your heads. Feel free to use your calculator. I'm glad you're both back, actually. There was a moment where I thought, oh, one of you has disappeared, because it was only one of you coming to every lesson. Anyway, here we go. Shh. We see the M, so straight away we're writing down our slope formula. Okay, so slope. Oh, and I'll keep Mr. Adams happy. Change in y over change in x. So someone just asked, why isn't it S? S for slope. So this is what we started with in the first lesson. You might have been away, and we said if someone could actually find out why they call it M.
There were 2 possible reasons.
Well, one of my students in another class said in France. Oh, that was here? Yeah. To climb means something. They had Monty, whatever. So we went with that. But normally, little s in mathematics and physics means speed. So it's already used. And technically, you could argue m is mass. Again, already used, but hey, we go with it. Okay, so we write it down. We're going to go minus 3 over 8 equals. Who would like to tell me what to write for the top line? 9 plus 2. We're saying 9 minus 2, right? So it becomes plus 2. And because Leon started here, and I love that you did start there because now I've got my C, it would be C take 14. So this one is a little bit different to the last one because the last one, our unknown was upstairs. Here, our unknown is downstairs. Now, what can we do? What do you mean swap it? Turn the thing around. So you can cross multiply. Is that what you were meaning? Like turn, but do you know what I was hoping you was saying when you say turn it around? Could we not just flip them? So cross multiplying, you can absolutely cross multiply, and you'll probably end up with the same answer that we do anyway. But we can actually also flip. So minus 8 over 3 can equal C take 14 over 11. Are you sure we're allowed to do that? Well, why is the negative still on top? Just because that's how I write a negative fraction. Right? It doesn't matter. You still end, yeah, the whole thing is a negative. Don't be sorry. That's great. Okay, and we can do exactly what we did before. So 11, get rid of the divide by 11 times. We get minus 88 over 3 equals C take 14. How do we get rid of the take 14? Plus 14, right? Pop it in your calc. Leon, if you said before, if you wanted to cross multiply, so if you wanted to go 3 times C take 14 equals 8 times 11 is 88, guess what? You will end up with exactly the same answer that we do. Which method would I do? Oh God, it depends what mood I'm in and what my pen decides to write first. Mix it up. Okay? So, it's now time for you to sort of work your magic and work your way through those tasks. I'm just working your way through. Okay? Over and out. You've missed me, but as you have finished your slope questions, we should be cruising through. What will happen is you will have an exercise, because you might be thinking we're going bang, 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 bang. You will have an exercise where it groups all of these together. So if we have a look, we're doing the perpendicular. So we just said perpendicular means at right angles. So if you think about it, if I have something like this, how would you describe this slope? Yep. What about the size of it? Would it be? It's pretty steep. So give me an estimate for the slope. Yep, 8. Like it's high. Let's go. Let's imagine this is slope, and you just did automatically. It's also positive, right? Because it's increasing. The perpendicular slope. Two things that it's different with the steep one. It would be not so steep, and it's negative, right? So would it come as any surprise to you that this would actually have a slope of minus 1/8?
Wouldn't surprise me.
It wouldn't surprise you in the slightest. So if we have a slope, you might remember this from last year, but we've got AB. The perpendicular slope is you flip and reverse the sign. That is called the negative reciprocal. Negative reciprocal.
Am I supposed to remember that?
No, but you might. Did anyone remember that at all? Like it did it. Okay, fair enough. So if we had 2/5, what would be my perpendicular slope? Negative 5 over 2. What if I had minus 4/3? What would be my perpendicular slope? We've got minus 4 over 3. What would be my perpendicular slope? 3 over 4. What if I had, let's go with, we'll stick with this. What if it was 5? What would be my perpendicular slope? Oh, we just did that there. Yep, minus 1/5. You think you're so smart? Well done, well done. What if I had 3.5? What would be my perpendicular slope then? Yeah, Dave? It wouldn't be negative 1 over 7.
Negative 2 and 2/30.
So Dave's got the right idea. He's doing it in his head. 3 times 2 is 6 plus 1. So that's 7 over 2. So my perpendicular slope would be Negative 2 over 7. Can I... You, come and sit here. You. Have a look at these. What happens if you multiplied these two together? What answer do you get? You don't get 0, not 1. You get negative 1. What if I multiplied these two together? So when you multiply a slope with its perpendicular slope, you get negative 1. Do you need to come and sit up here? So you're going to be asked about some of this in a minute. Again, look at OneNote to see what questions you have to do. And the last thing before I sign off is, what does I might have spelt that wrong. What does collinear mean? Maybe there's only one L. What does collinear mean? If 3 points are collinear.
They're all like parallel.
No, they're not parallel. So 1, 2, 3. These points are not collinear. I should make them a different colour.
Oh, surely 12 and midpoint.
So not collinear. These points are collinear.
They're all on the same line.
All on the same line. Now, if they're all on the same line, and maybe I get this point, maybe I only have part of this point, and I have this point. How could I work out a missing value in here? Could I? No, not really, because I don't really know the distance, and if I've got lots of points, what else could I use? I mean, maybe you could do distance, would be a lot of work. Slope. Why? Because when they're collinear, the slope from here to here is going to be the same as the slope from here to here or here to here. When they're not collinear like this, then you can't use the same slopes because that wouldn't work. But collinear, they're on the same line, aka they will have the same slope. So keep that in mind. So remember, so you'll see 11D.1. Some of you could actually work with a partner. And let's say we'll just do 1, 2, actually no, I like all of that. We like all of that. But look at the first one. You might decide, I'm not actually going to write any of that down. Find the gradient of all lines perpendicular to. So, what's perpendicular to? Negative 2. Miles will have to do them all because he's not listening. Yep. Oh, sorry, I'm recording this and you can't hear them. So we just did number 1 verbally as a class. Number 2, how could you test each other on that? The gradients of the 2 lines are listed below. Which ones are perpendicular? So how can you tell if they're perpendicular or not? Are these 2 perpendicular? No. So 2 ways. You can either look at the 1/3 and say I'm going to flip, and you have to reverse the sign. So it means it has to be -3. That's not -3, so no, they're not perpendicular. What's another way that you could do it? Times them together and you should get -1. Not 1 or -1, you have to get -1. So in this case, when you times them together, you get 1, no cigar. Here, 5 times -5, well, 1's positive, 1's negative. That's great, but 1 is not the flip, the reciprocal of the other. So no, no. 2 3s are 6 plus 1 is 7, -7 over 3. Yes. So your choice as to how much you write down for this. You could quiz each other, but I'm assuming you skip it. It means you have understood perpendicular lines. Are we happy? So 11D1. Oh, geez. Okay, let's just do it up to, let's just do it up to 5. Oh, actually, no. So this is doing all, and now we're looking at distance, midpoint, parallel. So it's using all of that stuff that you did before. This pulls everything together. Okie dokesters? Go your hardest.